Let us quickly solve this problem. The diagram below represents part of a wave motion in air. If the wave travels with a speed of 300 meters per second, calculate the frequency of the wave. And the first thing is that bring out your parameters from the question. So if the wave travels with a speed of 300 meters per second, so it means that the speed of the wave is 300 meters per second. So V is equals to 300 meters per second. Now, calculate the frequency of the wave. Find the frequency. It means that we are looking for the frequency. So our frequency equals to, we don't know for now. We don't know the frequency. We are looking for the frequency. Now, by now, you should know that the formula we are going to use to calculate our frequency is going to be from V equals to frequency times what? Wavelength. That is, the speed of the wave is equals to frequency times what? Times wavelength, right? But now, we have our speed, which is 300 meters per second. We don't know our frequency. We are looking for it. It means that we must know our what? We must know our wavelength, because we cannot find two things at the same time here. Now, and that is why the question gave us this diagram, to be able to find our wavelength. Now, if you go to the diagram, you'll see that the distance from here to here is 3 meters. Now, does that mean the wavelength is 3 meters? No. One thing you need to understand first is, what is wavelength? Wavelength is the distance covered by the wave in one cycle, in one complete cycle, or oscillation, or vibration. So now, where is one cycle on the wave diagram? So here, from here like this, when the wave travels like this, to this point here, that is one complete cycle. So meaning that if you move from here like this to this point again, that is another what? That is another cycle. So meaning that if you move from here to here like this, that is only half a cycle. Now, we are interested in the wavelength. We want the wavelength now. But now, the wavelength is from here like this to this point here. So meaning that the distance from here, our wavelength is the distance from here to here, like this. That's what we want. But the question gives us the distance for the whole cycles, right? Now, how do we get that? Well, we can get this by simple proportion. Now, the first thing is that, what is the total cycle that will give us these 3 meters? Now, let's calculate it. This is from here like this to this point. That's one cycle. Here like this to this point. That's another one cycle. That's 2 cycles, right? So from here to here like this is half a cycle. That is 2.5 cycles. Is the one giving us these 3 meters. So meaning that we can say like this, that 2.5 cycles represent what? Giving us 3 meters. You can see the number of cycles here like this is 2.5 cycles, and the total distance is 3 meters. So it means 2.5 cycles represent what? 3 meters. But you should know that our wavelength that we are looking for is just the distance in one cycle. So if 2.5 cycles is 3 meters, then one cycle will give us what? Will give us how many meters? We don't know. Let me put X there for now. So if the distance that we get for X will be the distance for what? Will be our wavelength. So now, what do we normally do? This simple proportion, we can cross multiply like this. Like this. So it means that X times 2.5, that is what? 2.5X equals to 1 times 3. That's going to give us what? That's going to give us 3, right? So I can divide this by 2.5, right? 2.5. So this cancel this. And what is going to be my X here? Now the thing is that you can use your calculator to divide this, but I'm not using calculator here, and I'm going to do something here. So, but don't bother, just use your calculator. Now, if I multiply this by 10 over 10, like this, so my denominator is going to go away from decimal. So here now, this is going to be equals to 30 over 25. So now I can say 5 here 6, 5 here what? 5. So now I'm going to leave my, that means my wavelength now is going to be 6 over 5 what? 6 over 5 meters. So this is going to be 6 over 5 meters. Why did I not turn it to decimal? Because I'm not done. I will still need to bring it here, and I'm not using calculator. So let me just leave it as a fraction like this. Now, remember, we looked for the distance for just one cycle. And distance for one cycle is our wavelength, right? So meaning that this 6/5 meters is our wavelength, right? Now let's come back here now. It means that from here now, I can say our wavelength. So our wavelength now is now equals to 6/5 what? 6/5 meters. So I will come here now and substitute the parameters that we have here. But before you substitute, there are two things. You can substitute like this, or you can first of all make your wavelength the subject of the formula, anyone you like. But now let me just say my V is 300. So I'm going to put 300. Anywhere I see V, my V is 300. I'll put it here, equals to frequency times, what is my wavelength? That is going to be what? 6/5. So I'll say times 6/5 like this. Am I right? Now the thing is that this is going to give me 300 equals to F times 6. That's 6F/5, right? Now this has turned to a fraction, so I can actually put over 1 here and cross multiply. Remember that all these things will not take you time if you are using your calculator. So if you cross multiply, that will be equals to 300 times 5 equals to 6F. So you can divide this out by what? 6 here like this. So that you can have your F. So divide this by 6, divide it by 6. So 6 cancels 6, and your frequency is going to be equal to, now, how many 6? 6 here, 1, 6 in 300. First of all, say 6 in 30 is going to give us what? 5. So that's going to be 50, right? So 6, that means 6 in 300 is 50. So 50 times 5 is going to give us what? 250. Now the question is, what is the unit of frequency? That's going to be Hertz. So, and that is why our frequency is going to be 250 Hertz. Thank you.